Last time we looked at supply and demand analysis, and there's a particular reason for doing that. We were interested to establish how market prices get determined. And we saw that we could use supply and demand analysis to see how prices of goods and services get determined in a market system to deal with the problem of scarcity. And we also saw that if there were changes in demand or changes in supply, market prices could adjust. So for example, if there's an increase in demand, we saw the price will rise and the quantity will rise. But we've only really been dealing with the direction of changes in price and quantity when there are shifts in demand or supply. We haven't begun to work out how to measure the extent of the change. So for example, suppose the price falls. We expect people to buy more. Yeah, but how much more? Does a given fall in price lead to a huge increase in the quantity demanded, or just a little one? If there's a rise in price, does it cause suppliers to increase the amount that they're selling to the market by a little bit, or by a huge amount? So we're interested in the sensitivity of consumer demand and supplier behavior to price changes. And we need to find some way of quantifying the extent of the change for a given price change. So what we're going to do here is to do that mostly by focusing on demand, and then at the end we'll have a little look at supply. So we'll think first of all about the nature of the demand curve and say, how sensitive is consumer demand to price changes? And the term we use for this is the elasticity of demand. How sensitive, how elastic is the demand as a result of a change in the price? And we'll do that with a simple formula. And the formula that we're going to use is this. We're going to look at a price change and say, what's the percentage change in the quantity demanded for some given percentage change in the price of the good? And I've called this the own price elasticity of demand for reasons that you'll see more clearly in a minute. But we're asking the question, when there is a change in the price of a good, what's the change in the quantity of that good demanded? We want some proportionate change, and in this case, we'll use percentages. Why do we use proportionate and not absolute changes? Well, if you take an example, it becomes easy to see why. You go into the shop to buy a bottle of wine, and the price was €5, and it's been reduced to €2. What are you going to do about purchasing the wine? That's a very considerable drop in price and may well lead you to a considerable increase in the amount of it that you're willing to buy. Suppose now you go to a car showroom and there's a Mercedes for €300,000, and the salesman offers you a €3 reduction in the price. You're going to be less than impressed, but it's the same drop as it was in the case of wine. It's a €3 fall. Yes, but that's not the point. The point is that proportionately, the drop in the price of the Mercedes is much, much less than the drop in the price of the bottle of wine. What is going to drive your decisions is not the absolute price fall, it's the proportionate price fall. So our measure is to take the proportionate change in the quantity demanded and divide it by the proportionate change in price. Let's take a particular demand curve and work through some numbers so that we can see that. Here we've got some given demand curve such that when the price is 10 euros, the quantity demanded is 10 units. It's a straight line demand curve. When the price is 8 euros, quantity demanded is 20. At 6, it'll be 30. At 4, it'll be 40. And at 2, quantity demanded will be 50. Now let's suppose that at the moment the market price is 10 euros and consumers wish to buy 10 units. Now let's suppose that the price falls to 8. How sensitive are consumers to this change in price? Well, here's our measure of elasticity. We take the percentage change in the quantity demanded and divide by the percentage change in price. What's the proportionate change in quantity demanded? It's doubled from 10 to 20. We've got 100% increase in the quantity demanded. And what's the proportionate change in price that caused that? A 2 euro fall expressed as a percentage, 20%, 2 over 10, a 20% fall in price, minus 20%. So what's the elasticity of demand? 100 over minus 20 is equal to minus 5. The elasticity of demand is minus 5. What does that mean? What is this number? One way of expressing it is to say, on average, for every 1% fall in price, there's a 5% increase in the quantity demanded. How did we get that number? We divided the percentage change in the quantity demanded, 100, by the percentage change in price, 20%. 100 over 20 gives us 5, or more strictly, minus 5, because it was a fall in price for an increase in the quantity demanded. So consumers are pretty sensitive to price changes. For every 1% fall in price, a 5% increase in quantity demanded. Now let's see what happens to this sensitivity to price changes as we move down this straight line demand curve. Suppose now there's another cut in price from 8 to 6. What's the percentage change in the quantity demanded? It rises by another 10, but this time, of course, it's only a 50% increase in quantity demanded, because it's a 10 unit increase on a bigger amount, on 20 rather than 10. So we've got a 50% increase in quantity demanded, and although we've got another 2 euro fall in price, it's a smaller proportionate change. It's only a 25% cut in price. So what's the elasticity of demand? 50 over minus 25 is minus 2. That is to say, for every 1% fall in price on average, there's a 2% increase in quantity demanded. So it's fairly sensitive to change in price, but not so sensitive as it was at higher prices. Now let's just continue that and see where this takes us. Here we've got a fall in price from 6 to 4. That's a fall in price of a third, 33%. What's the change in quantity demanded that we get as a result? It's a third, 33%. What's the elasticity of demand? 33 over minus 33 is minus 1. For a 1% fall in price, we get a 1% increase in quantity demanded. We'll just do this calculation for one more price fall. Suppose the price falls from 4 to 2. We've now got a 50% fall in price that leads to a 25% increase in quantity demanded. 25 over minus 50 gives us minus a half. For every 1% fall in price, there's a 0.5% increase in the quantity demanded. In general, we would say that if the proportionate change in quantity demanded is greater than the proportionate change in price, we would say that demand is elastic. So in this part of the demand curve, consumers are very sensitive to price changes. Demand is elastic. But as we move down the curve, demand gets less and less elastic. At some point, the proportionate change in quantity demanded is the same as the proportionate change in price. So the elasticity, ignoring the sign, the absolute value is 1. We would say that demand is unitary. For a lower price, we would say that demand is inelastic. The proportionate change in quantity demanded is less than the proportionate change in price. So if the absolute value of the number ignoring the sign, if the absolute value is greater than 1, demand is elastic. If it's less than 1, it's inelastic. As we move down this demand curve, we move from an elastic demand to a more and more inelastic demand. So we've established an idea now about the elasticity of demand. How could we use that? Why does it matter? Well, one of the reasons why it matters is that it tells us about the relationship between the amount that a firm or a group of firms will sell and the amount of revenue that they'll receive. Or to put it another way, it tells us the relationship between the amount sold and the amount of expenditure by consumers on the good. Can you see that if demand is elastic, if there's a small drop in price, let's say of 1%, and there's an increase in the quantity demanded of, let's say, 5%, the amount of expenditure on the good is going to rise. The proportionate increase in quantity demanded is greater than the percentage decrease in price. Demand is elastic, so a cut in price causes revenue to rise. See that on the diagram and see what happens when demand gets less elastic. Here's the demand curve that we had a few minutes ago, and I've plotted underneath another diagram which shows us the quantity along this axis, but this time the revenue that firms receive, or to put it another way, expenditure by consumers on the good. If the price were to be 12, it's so expensive that nobody buys, and revenue, expenditure on the good, is 0. If price comes down to 10, 10 units are sold at a price of €10. 10 times 10 means that the revenue that firms receive, or to put it another way, the expenditure on the good, is €100, 10 times 10. Suppose they cut the price from 10 to 8, 20 units are sold. How much revenue is received by the firms? It goes up from 100 to 20 times 8 is 160. Revenue rises when the price falls. That's because the proportionate increase in quantity demanded is greater than the proportionate decrease in price. Revenue is rising. But now observe what happens if price falls again. 30 lots of 6 is 180. Revenue continues to rise, but not by very much. Demand is getting less elastic. If we go on cutting price, we can sell 40 units at 4. Total revenue is 40 lots of 4 is 160. Revenue is now declining. If we cut price when demand is inelastic, revenue falls. 50 times 2 is 100. And of course, we maximize sales by giving it away. You can get rid of 60 units if the price is nothing. But of course, if you do that, you have to charge a zero price and revenue falls to zero. So now we've established the relationship between the elasticity of demand and the amount of expenditure by consumers, or the amount of revenue received by firms. When demand is elastic and price is cut, revenue rises. If demand is inelastic and price is cut, revenue falls. And of course, the reverse will be true if we talk about price rises. So if we just come to the table that I've got for you here, what happens if there's a price decrease? That's what we've just done. If there's a price decrease and demand is elastic, there's an increase in revenue. If it's unitary, 1% price cut, 1% increase in quantity demanded, no change in revenue. More is sold, but no change in revenue. Cut price when demand is inelastic, and there is more sold, but a decrease in revenue. If we move up the demand curve, if we start off with an inelastic demand and we increase price, revenue increases because the proportionate increase in quantity demanded, the proportionate decrease in quantity demanded is less than a proportionate increase in price. Revenue rises. No change for a price increase if it's unitary. But if we try to raise price when demand is elastic, we'll find that revenue decreases. So it's clearly very important for the companies to know how sensitive consumers are to price changes. If we try raising our price, what's going to happen to our revenue? We'll certainly sell less, but will our revenue rise or fall? We can establish something further. We now know that if companies are able to raise price when demand is inelastic, they'll do so. They can get more revenue for selling less. That's got to be a great idea. Does it make sense to raise price when demand is elastic? Now it's much less certain. It'll save us on costs, we'll produce less, but we're going to get less revenue. So is it a good idea to raise price when demand is elastic? We won't know the answer to that until we've done something on costs of production. But we already know that it will always be a good idea to raise price when demand is inelastic, because we can raise revenue for selling less. So companies will always wish to be on the elastic part of the demand curve if they possibly can. Now, what determines whether demand is elastic or inelastic? Well, we've already seen one thing. If demand is a straight line, which it might not be, if it's a straight line, it's going to be the case that the higher up the demand curve we go, the more elastic demand is going to be. But what other factors determine the elasticity of demand? There are quite a few, but the biggest one, the most important one, is this. Are there close substitutes for the product? If you raise the price of your product when there are close substitutes for it, demand, all other things being equal, is going to be elastic. They'll just give up buying from you because another product will do the job pretty well. If you're selling a product for which there is no close substitute, demand is likely to be inelastic. What else can they do? So if you are the only supplier of insulin to the market and you raise price, this consumer has nowhere else to go. If he doesn't buy the insulin, he'll die. The likelihood is that revenue will rise because demand is inelastic. Now, having seen that, let's try to figure out whether we've understood this correctly. Here's the problem to think about. The demand for cigarettes at the current price is pretty inelastic, right? How do I know that? I know that because most governments are anxious to reduce the quantity of cigarettes demanded. Sometimes it's for health reasons. Sometimes they just want to get more income. They want more revenue. So frequently the tax on cigarettes rises. And what happens to the quantity demanded? If your friends are like mine, they all say, that's it, I can't go on paying this price for cigarettes, I'm going to give it up. And they give up smoking for maybe 20 minutes or so, and then go on buying pretty much the same amount as they were buying before. Demand is clearly inelastic. But let's think about what we've said. Companies would never want to operate on the inelastic part of the demand curve. Why don't the companies raise cigarette prices, double them, triple them, until they move up the demand curve to the elastic section of the demand curve? Is this inconsistent with what we've been saying? Can you see the answer? The demand for cigarettes is inelastic. If all companies raised the price of cigarettes, their revenue would increase and their profitability would increase. But the demand for any one brand of cigarettes is highly elastic. There are close substitutes, other brands of cigarettes. So companies fear to raise prices because consumers can easily switch out of their brand into some other brand. So the demand for one brand of cigarettes is highly elastic. The demand for cigarettes as a group is highly inelastic. So companies would like to get together and all agree to raise the price. And that's precisely why governments usually have laws preventing firms from operating together to prevent them from doing so. But what we've seen about the nature of the demand for cigarettes is perfectly consistent with what we've been saying about the nature of the demand curve. So that's the own price elasticity of demand for cigarettes. And indeed, we can take the same principles for any other good. We've looked at own price elasticity of demand. Now there's a second idea that we'll think about now, and that is called the income demand elasticity, or more commonly the income elasticity of demand. And this time we ask the question, suppose there's a change in income. What happens to the demand for a particular good? Now, one way of illustrating that is to do it via our demand curve. And we did that before. We can take an ordinary demand curve with the price here and the quantity here, and here's our own price demand curve, and we can say what happens if income rises. For most goods, the demand curve shifts out to the right. At higher levels of income, people can buy more of the good than they can buy before. So for the great majority of people, there's a rightward shift in the demand curve as income rises. Those are normal goods. As we'll see in due course, there are a few goods where as income rises, demand actually falls. These are called inferior goods, where as income rises, we can afford a better substitute. So the demand for sausages might fall as income rises because people can now afford steak instead. But for most goods, as income rises, the demand curve shifts out in that way. But there's an alternative way of expressing that, and we can do that via what is called an income demand curve. This time we plot income, which I'll abbreviate as Y up here, and put the quantity demanded along here and ask, when income is low, the quantity demanded is this much, so average incomes are now 1,000 euros a week. Quantity demanded is this relatively small amount. As income rises to, let's say, 2,000 euros a month or whatever it is, for most goods, the quantity will rise. So if at 1,000 euros, 100 units a week are demanded, at 2,000 euros, 200 units, say, are demanded. And at 3,000 euros, 300 units a week are demanded, and so on, we'll say. So this is a normal good, as it's not an inferior good. As income rises, the quantity demanded rises. So we're showing the same information as we showed just now, but this time via an income demand curve. We haven't got price up here, we've got income. So we've got an income demand curve, which looks like so. And we can use an income demand curve to measure the income elasticity of demand. And we can do it very similarly to what we did for price elasticity of demand. We ask how sensitive are consumers this time to changes in income by saying, let's look at the percentage change in quantity demanded and divide it by the percentage change in income. So for example, when incomes are 1,000 euros, we have 100. At 2,000, we have a quantity demanded of 200. So here, the percentage change in the quantity demanded is 100%. It's doubled. It's gone up by 100%. Percentage change in quantity demanded, 100. And what was the change in income that caused it? Income went up from 1,000 to 2,000 euros. There was a 100% increase in income. Percentage change in quantity demanded divided by the percentage change in income, 100 over 100 equals 1. What does that 1 mean? It means that on average, for a 1% change in income, we would expect a 1% change in the quantity demanded. Now, of course, it won't always be 1. Sometimes we will have income inelastic demand. When income rises, the quantity demanded doesn't rise very much. For other goods, when income rises, quantity demanded rises very considerably. We have an income elastic demand. So, for example, it's known that restaurant expenditure is very sensitive to changes in income. When our incomes rise, we all go out and eat much more. When there's a recession and incomes are falling, we all switch to eating at home, and demand for restaurant expenditure falls very sharply. So restaurant expenditure is very sensitive to changes in income. We've established an income elasticity of demand. Now, one more example of elasticity that we need to look at is the cross elasticity of demand, where this time what we do is we look at what happens to the quantity of one good demanded when the price of another good changes. Now, we've already done that. In the last lecture, we said, if there's a given demand curve for apples, what happens to the demand for apples when the price of pears changes or orange changes? And we shifted the whole demand curve. We said there is a change in the demand for apples. There's an alternative way of showing that same information, and that is to think in terms of a cross price demand curve, where we plot the percentage, the change in the quantity of one good demanded against the change in the price of another good. So what would that look like? It looks like this. We take the percentage change in the quantity demanded of good X and divide it by the percentage change in the price of good Y. So if we were to draw the demand curve now, how would it look? Here's the price of oranges. Here's the quantity of apples demanded. So we're asking what happens to the quantity of apples demanded when there's a change in the price of oranges. So the price of oranges is at the moment €3, and the quantity of apples demanded is 1,000. Now we'll ask, suppose there's no change in the price of apples, but the price of oranges changes, what happens to the quantity of apples demanded? Let's suppose that the price of oranges now falls from €3 to €2. Oranges become cheaper, and people buy more oranges and less apples. So at €2, the quantity of apples purchased tends to fall to, let's say, 500, as people switch out of apples into the relatively cheap good oranges. So we've got a cross demand curve which looks something like that. That's the demand for apples with respect to the change in price of oranges. Now, how sensitive is the change in the quantity demanded of apples to the change in the price of oranges? You can guess how we measure this. We look at the percentage change in the quantity of one good, in this case apples demanded, and divide it by the percentage change in the price of oranges. We had a fall in the price of oranges of a third, 33%. And it caused a change in the quantity of apples demanded of 50%. So we have a 50% change in the quantity of apples demanded for a 33% fall in the price of oranges. So what's the cross elasticity of demand? It's somewhere around about minus 1.5. What does that number mean? For every 1% fall in the price of oranges, we're going to get a 1.5% fall in the quantity of apples demanded. This information is very useful to suppliers of goods to know the reaction of consumers, If we've got some control over price and we cut and we cut price, we know not only what's going to happen to the demand for our product, but what's going to happen to the demand for competitors' products as well. We know now if they cut their price and we don't change our price, what's it going to do to the quantity demanded for our good? That's the value of the cross elasticity of demand. And if two goods are substitutes for one another, we're going to get this positive relationship. Sometimes goods are not substitutes for one another, they're complements for one another. So price of petrol has a relationship to the quantity of cars demanded. They're complementary goods, they go together. When the price of petrol rises, the quantity of cars demanded falls. Plot that on a diagram with the price of petrol at one axis, the quantity demanded of cars along another axis, and you should see that you've got a negative relationship. So when we plot the cross demand curve, a positive relationship indicates substitutes, a negative relationship indicates complementary goods. Now in a moment we'll look briefly at supply elasticity, but just before we do that, just want to look at one example of elasticity of demand in the context of a particular firm to see how we might use this information to see what happens to ours and competitors' quantities and how the market is affected. And we're going to do that by looking at something that happened a few years ago in the market for what are called quality newspapers in the UK. Newspapers of the loosely called quality kind. We have the Times, we have the Telegraph, the Guardian, and the Independent. And these newspapers compete with one another. And a few years ago, the price of the Times was 45 pence per copy. And the Times decided to see what would happen if they sharply cut the price of the Times. What would happen to the change in the quantity demanded? So what they did was to take a small area of the country and for 1 month offer the Times at a big discount. They cut it from 45 to 30 pence. That is to say, a 15 pence change on 45, a 33% cut in price, and observe what happened to the quantity of the Times sold and to the quantity of the other newspapers sold in that area as well. And we can see the result and think about the elasticities of demand and see what it meant for the marketplace. Let's see what happened and see where we get to. Here's the data. In this one area, the Times has just been cut by 33%. The effect on the Times in that month, in that 4-week period, was for 14.7% more copies of the Times to be sold. Not surprising that quantity demanded rose when the price fell. What happened to the demand for other newspapers whose prices didn't change? These are substitute goods, and they all found to varying extents that the quantity demanded fell when they didn't change their price, but the price of the Times fell. They're substitute goods, hence the negative sign that we get here for the cross elasticity of demand. Total number of newspapers sold in the market tended to rise a little bit. Again, not surprising because on average newspapers are now a little bit cheaper. But look at these numbers and we've got an idea of elasticity. The percentage change in the price of the times was minus 33%. The proportionate increase in quantity demanded is 14.7. So the percentage change in quantity demanded, 14.7, over the percentage change in price, minus 33, gives us a number of somewhere around about 0.5%. A 1% fall in the price of the times gets us 0.5% increase in quantity demanded. We could also make calculations about the cross elasticity of demand. We've got, for example, a 5.9% fall in the quantity of the Guardian demanded when there's a 33% cut in the price of the Times. So we can do our calculation and work out the cross elasticity of demand for the Guardian with respect to the price of the Times. Now, if you were advising the Times, would you go national with the price cut? 33% fall in the price, you get a 14.7% increase in quantity demanded. Demand is clearly inelastic. Does it therefore make sense to cut price? It looks not. You're selling more newspapers, but your revenue is declining. So on the basis of what we've said, you would expect the Times to say, interesting experiment, we've discovered something about the elasticity of demand, it's not worth cutting price. And the Times went ahead and cut the price. How can we make sense of that in the light of the data that we've just seen? Well, it illustrates an important idea. The elasticity of demand in the short run may be different from what it is in the long run. In the short run, the Times is still competing against these other newspapers. But suppose the effect in the longer run is to cause one of these newspapers to have to go out of business because they've lost some sales. Then the result will be that lots of those people who were buying the newspaper which no longer exists will go and buy the Times. So this is a short run elasticity of demand. The Times hoped that they would drive the independents out of business, and in the long run, the sales of the Times would increase far more. It didn't work. They found that even in the longer term, the independents survived, and after a while, the Times went back to 45 pence a copy, and indeed, having realised that the other newspapers were still in the market, discovered that they were on a relatively inelastic part of the demand curve, and subsequently the price in the Times has risen by much more than the rate of inflation. They've moved up the demand curve. So you can begin to see how you can use concepts of elasticity of demand to look at real problems in the world. We're not just looking now at the direction of price changes and quantity changes, but we're able to measure the extent. Finally, just one word about elasticity of supply. What we've said about demand elasticity, we can say about supply elasticity. We can ask the question, if there's a change in the price, how sensitive are suppliers to changes in the price? Will they supply much more to the market or just a little bit more? So let's, in the last few minutes of the lecture, look now at this idea of the elasticity of supply. And our measure, as you've probably guessed by now, is to take the percentage change in the quantity supplied and divide it by the percentage change in the price of the good. This is the elasticity of supply. So if, for example, we find that the price of apples or whatever good we're talking about is 50%, to what extent will suppliers increase the amount they sell in the marketplace? Let's say they offer another 100%, the quantity supply doubles, then we would have the percentage change in quantity supplied over the percentage change in price is 2. What's the significance of that 2? It says for every 1% increase in the price, there'll be a 2% increase in the quantity of the good sold. If we were to now to draw what that looks like, it looks something like this. If we draw a supply curve like so, and we calculate the elasticity of supply, and you can do this for yourself, you'll find that at any point along this supply curve, the elasticity of supply is equal to 1. A 1% change in price causes a 1% change in the quantity supplied. If, however, the supply curve cuts the vertical axis, and you had a supply curve like S dash, you would find that if you calculate the elasticity of supply, it will vary as you move along the supply curve. But at any point, this is an elastic supply. The proportionate change in quantity demanded, the proportionate change in the quantity supplied is greater than the proportionate change in price. Finally, if we had a supply curve which cuts the horizontal axis, like S star, although the value of the elasticity varies along the curve, we would find that at any point we would have an inelastic supply. Suppliers are less sensitive to changes in price. There's a less than unitary elasticity of supply. There are many things which determines the elasticity of supply, but perhaps the most important one is the time period. If there's a rise in price, suppliers will want to offer more for sale on the market. And sometimes they can do that relatively easily. But for other things, in the short term, they're unable to increase supply very much. If the price of raspberries rises, they would like to offer more raspberries for sale. But they've got to plant more canes, wait for them to grow. So the sensitivity of supply to changes in price is really not very elastic in the short run, but in the longer run, they can more easily respond to changes in price. So supply elasticity is greater in the longer run. That's true for many, many goods. So what have we seen so far? We began by saying we've got this scarcity problem that we have to solve. One way of doing it is to use markets, particularly market prices. So then we looked at how market prices are established, introducing supply and demand curves. Now what we've done is taken the analysis one step further and seen not only what happens to prices and quantity when supply and demand alters, but we're able to measure the extent of the changes. And that's going to be important for us in understanding how markets react over time.